now that we've done the determination of the limits from graphs, we have a visual of what's actually happening. And one of the things that we stressed was that we have a function, okay? Maybe a function is going like that, then we have a point there. So we could see that when we're trying to get a limit, we're actually trying to get as close as possible to that point there. All right. So this is what we are saying. We're saying that we are approaching that constant. And so the notation that we used was this, to say that maybe we're approaching 2, or we're approaching a limit that would call maybe a. Okay. Now, when we are doing algebraic computation, it's a little bit different, because now, like we said, that we are trying to advance we're trying to advance how much we can do with, let's say, mathematics, for lack of a better term. Because you remember that whenever we were doing calculations and we reached a point where, for example, we reached a point where now we have to divide by 0. Okay, we normally stopped here, but now we're trying to advance a little bit closer to what is actually happening, maybe at a state like this. Because remember, we also found, for example, we would reach a point where we said -1, and we said that this is impossible at some point in our education. But then we advanced, and then we said that, okay, now we'll say that this is -1 is I. And so that's what we're trying to also see here. What is actually happening closer to this? So when we get the determinate form, we should consider the fact that this is not the end of it all. There's still some manipulations that we can do to actually work with an expression that gives us this end. Okay, so we can do simplification, we can do factoring, we can do conjugates, we can do a lot of things, and that's why at some point we'd emphasize that in all of mathematics, I think we try to aim for simplification, and whatever you do has elements of simplification. So for example, I'm solving an equation, I'm trying to get to, from all those expressions, or the variables, the constants, the operations, the exponents. I'm trying to get to a point, for example, if I'm solving for x, where I could say maybe x is equal to 1. So that's a simplification of maybe let's say 3 equations. We simplify them into 3 numbers. Okay, we reduce them into 3 numbers. So for me, this is probably the most important activity in all of science, because we try to see complex structures, complex equations, complex numbers. We're trying to see them as maybe a single number or a few numbers that can easily be explained. So these are just helping with simplification. So we know that we can do factoring, we can do conjugates, and things like that. But the key thing is that we need to circumvent this form whenever we're doing, where this is actually appearing, or where an end is actually coming to this. We need to be able to circumvent this. So the skill that you need with limits is actually the advanced skill rather that you need is to be able to circumvent this, because some equations will just be as easy as, let's say, for example, I say, what's the limit of this function? Okay, let's say limit x minus 1 as x is approaching, let's say 2, right? This is easy because I can just put 2 minus 1 is equal to 1. I don't need a special skill here, isn't it? But then now we'll see how this can get complicated when we start meeting things like this. Okay, so this is the bridge from let's say using the graphs to using computation. And so I've also referenced this website. www.ucdavis.com. This is where we'll borrow a list of problems that we will solve. We got the permission to use the problems, and obviously we can't use their solutions, but we'll have to work out our solutions. But I love how they've listed their problems, and I think it will help us to see to find pathway through curriculum. So we'll mostly use this website. You can visit them. They have a lot of good things happening there. It's free stuff, so nobody's sponsoring anybody. Right. All the best.